So this is the second part of the video and of section 1.2, and what they're asking you to do is just write this example in roster form, which is what we've mentioned in the first one. So basically just listing the elements of each set. So when we ask for x such that x is a natural number greater than 100, we want to open our brace. The first number greater than 100 would be 101. That is also natural because we're following this natural number pattern. And then going up from there, 102, 103, and I think once a pattern is clearly distinguished, you can just put ... These are called ellipses, by the way, to say that that pattern goes on forever. So then same thing with letter B. X such that x is a whole number between 1 and 6. We'll look back at your whole numbers. Well, if we want to be between, I would say the first whole number bigger than 1 would be 2. And then this one definitely stops. And I would not include 1 or 6 because it doesn't say to include. So I would stop once I get to 5 and then say that's my answer. So just a few more things. So this is exercise 4 and 5. I just combined them together out of your textbook. A few more things as far as math goes is we have this symbol up here. Let me highlight it for you. It kind of looks like a less than symbol, but it's more of a U shape. You know, there's a curve there, and that means it's a subset of. So when we see that symbol, what we're saying is every element that's in one set is also in the other. And I kind of should just go down to exercise 5 to explain that. But I'll wait. And then same thing with this symbol right here. This means is not a subset. And now that I'm looking at the notes, there's also this goofy symbol that looks like an E. Basically, this uses the phrase, this is an element. That's why it looks like an E. So basically it's asking, is 3 a natural number? So this is a true statement, because if you go back, and I could go back a slide, might as well do it, I have plenty of time. Is 3 one of the natural numbers? And that answer is yes. So 3 is an element of the natural numbers. So that's a true statement. So looking at letter B, is 7 not an element? So we put a slash through the E. That's basically all that's saying. 7 is not an element when we put a slash through it. And as you look at this set has the numbers, the elements 1, 2, and 3. Is 7 part of it? Since it is not, so 7 is not an element, this is also a true statement. There we go. So letter C, -5 is a real number. Going back to what I explained as a real number, that's any rational or irrational. Since -5 is a rational number, this is a true statement. Letter D, is the square root of 8 a rational? Well, if you go to a calculator and you were to try and type in the square root of 8, it's like 2 point something, and all of these decimals do not end or repeat. Okay, so the square root of 8 is not a rational number, so this is a false statement. Please reach out to me if you're still confused by anything I'm saying. I'm going to scroll down. The next statement is saying every whole number is also a rational number. Well, think about whole numbers. That's the set that starts at 0 and counts up. You might need to go back to your notes to identify that these are your whole numbers. Well, a rational number is just anything that can be written as a decimal or a fraction. And this answer is yes. Every whole number is also rational. Yeah. And then letter F, if you recall, I talked about this is a subset. So what that's saying is every element that's in this set is also in this set. Well, if you're looking, 4 is also over here, but 2 is not. So since I found one that is not, then this is not a subset. Not a subset. In other words, this is a false statement. And what you should be thinking about as we do this and as you get to the homework is, are any of these subsets of each other? For instance, is the natural numbers a subset of whole numbers? Is every natural number inside of the set of whole numbers? Yes, it is. Are the set of whole numbers a subset of integers? Is every whole number also in the integers? That answer is yes. Are every integer inside of the rationals? That answer is yes. Now be careful. There are no integers that are also irrationals. So that is not, integers is not a subset of rationals. And then rationals are a subset of reals. Irrationals are a subset of reals. Now, this does not go backwards. The reals is not a subset of rationals, because there's plenty of real numbers that are not rational. And same thing with rationals are not a subset of integers. And I could speak all day about this, but I'm going to stop right there. Okay, moving forward, a few more definitions. There's a lot of definitions. This is why it's a 2-video day for this first one. The absolute value, I know a lot of people think of absolute value as always positive, but this is actually the distance from 0 on the number line. Now, it doesn't have to be the number line. For our purposes, we are talking about the number line. And distances are always positive. That's why absolute value is always positive. Now, opposite, that's where we negate things. So that's where negatives become positives and positives become negative. But absolute value is always getting you the positive value. And then the double negative property is basically saying, well, if you negate something twice, so a negative to a positive and then a positive to a negative, you get back to the original. So if you negate a negative thing, I'll put an A for whatever we're talking about. A negative of a negative becomes a positive. We're back to the original. And these should be things that are all familiar with you. Okay, so absolute value, that's exercise 6. We always want the positive version of that number. 4 is 4 units away from 0. Negative 1/2 is 1/2 units from 0. 1 is 1 unit from 0. Now this one, be careful, you want to do the absolute value first, and then the negative is still in front. Now be careful, because some people look at this and they say the negative of a negative is always positive, but you do the absolute value of -4 first, and then this negative stays in front. All right. Exercise 7, the opposite of each number, just positives become negative, negatives become positive, and positives become negative. Hopefully I've given you enough examples there. And then I believe this is your last, this is your last slide before you're ready for the homework. These are just a lot of keywords. I think I shared this PDF with you that you can copy this down so you don't have to write everything down. But look for keywords like sum, plus, added to, more than, increased by, or total for addition. Subtraction has all of these keywords. Now be careful when you see some words, subtraction the English language can confuse you. If you say, 3 less than 10, which I think is actually one of our examples down here. It's 5 less than twice a number. The English language actually confuses you, because if you say 3 less than 10, in my example, it's actually 10 minus 3, even though I said 3 first. So be careful with the English language. I'm not going to blame math here. It's English's fault. Multiplication, you have these keywords: product, times, multiply, twice. The word of, when you're dealing with fractions, like half of a number is 1/2 times, things like that. And then division, here's some keywords: divided by, quotient, what goes into, or the ratio. I kind of gave you that earlier. So exercise 8, again, straight from the book. Use X when you don't know the number. So the product of 3 and a number, that's just saying 3 times X. That's multiplication. I'm tired of writing in that color. So this is one of those less than words. so the English language confuses you, you want to make sure that it's -5. Twice a number means taking the number and multiplying by 2. So 2x minus 5 is that it translated into words. So 3 and 5/8 more than a number. So 3 and 5/8, that is a mixed number. I'll just write it like this, 3 and 5/8. More than a number means adding, so plus x. Keep changing colors. The quotient of a number and 2, that's just saying x divided by 2. I like the fraction symbol for division. Hopefully you're used to that. 14 subtracted from a number. So I would just write that as the number minus 14. The way that English language might be confusing to you. And then 5 times the sum. Well, because I see sum, that's telling me to put that in parentheses. I don't know why that's not showing up. Let me change colors. Hold on a second. There you go. It stopped working for a second. So the sum of a number, that's telling me to do x plus 10 in parentheses, and then 5 times the sum of it. So I'm sure you're familiar with grouping symbols, but sometimes the key word is your indicator to do a grouping symbol first. So that's the big thing there. So here's the assignment. Seems pretty large. And check with Google Classroom when it's due. Feel free to just write it on a piece of notebook paper, because I haven't had a chance to talk to some of you. Just make sure that you clearly label was 1.2. Your name will be attached to it, or you can put your name on there as well. And just make sure that you are clearly identifying what answer goes with which. And then we're going to figure out, you can either take a picture with your phone. I know there's programs that will change it to a PDF. You can send it to me through Google Classroom, or some other method to so you can get credit for doing your homework. So again, double check with me, contact me, Google Classroom, etc., and we'll get this figured out.